Hi guys, and welcome to Module 10. Module 10, we talked about expressions. In this slide, we're going to go over some vocabulary terms. The algebraic expression is an expression that contains one or more variables, and we know that variables are your letters or symbols that signify a value. And they also contain operational symbols such as plus, minus, times, or divide. So an example of an algebraic expression could be x plus 6. It has a variable. It has an operational sign. Another vocabulary term that we want to review is variable. Variable is a letter or symbol used to represent an unknown or unspecified number. The value of a variable may change. So based on the expression, your variable, coming from the word vary, can change. A constant makes a lot of sense because it is a specific number whose value does not change. So it is the complete opposite of what a variable would be. A constant does not change. We did an activity in class where we had to sort the words into the correct column to show which operation to use in an expression. So some examples of addition: added to, plus, sum, more than. Some examples of subtraction words are subtracted from, minus, difference, less than. Examples of multiplication are times multiplied by, product, or groups of. And division, some examples would be divided by, divided into, and quotient. We also were given the task to write a phrase as an algebraic expression, and if we're given the phrase of the sum of 7 and x, we would use our knowledge of the word sum as an addition word, which means we're going to combine 7 and x. So the expression would be 7 plus x. Similarly, if we saw a phrase like the quotient of z and 3, quotient is a division word, so automatically we would know to divide. We also know that order does matter when you are subtracting or dividing, so in this case, z would have to be the numerator and 3 would have to be the denominator. So the quotient of z comes first and 3. Some more examples: if I have a phrase like the product of 11 and x, the expression for that would be 11 times x. There are also some other ways that we can say that. We can say 11 groups of x or 11 times x. And another phrase, y less than 8, and we talked about the importance of this where in subtraction order does matter. So if we're taking y less than 8, that means that we're taking y from 8, and 8 would have to come first. So when we see those phrases, especially with subtraction and division, we have to be very careful because order does matter. When we evaluate expressions, we are solving for the variable. So if, for example, we have an expression like x minus 9, I wouldn't be able to solve that unless you gave me the value of x, and in this case, x equals 15. So it's a matter of just substituting and plugging in 15 for x. So 15 minus 9 is 6. And when x equals 15, then x minus 9, or 15 minus 9, would equal 6. Another example would be 16 divided by n, where n equals 8. I'm just going to substitute 8 and plug it in for n, and 16 divided by 8 equals 2. Yet another example would be 5/10 times y, where y is 1 4/10. So here we just need to review multiplying our decimals, and when we multiply 5/10 times 1 4/10, we get 7/10. So make sure that you remember to bring over your decimal point, and in this case, actually, let's go ahead and do this one. We're going to take 14 times 5. Remember, when I multiply with decimals, I'm going to pretend like they're not even there. And I'm going to take care of them at the end because I have to count over the decimal places. So 5 times 4 is 20. I'm going to carry my 2. 5 times 1 is 5 plus 2 is 7. Now I can worry about my decimal point, and I'm going to move it over 1, 2 times. And so my answer is 0.70 or 7/10 or 70 hundredths. In this slide, we review multiplying fractions. So if I multiply 6 times k, where k equals 1/3, I'm going to set up whole number 6 as 6 over 1 so that I can multiply him by 1/3. So if we went ahead and did that, 6 over 1 times 1/3, I remember that I can simplify. 3 goes into itself one time, goes into 6 twice. And so when k equals 1/3, 6 times k equals 2. Now, when asked to evaluate expressions using the order of operations, we want to make sure that we remember our parentheses comes first. So in this case, 4 times x minus 4 in parentheses when x equals 7. I'm going to plug in 7 for x, but I'm going to do what's in the parentheses first. So I'm going to do the 7 minus 4 first, and that equals 3. Then I'm going to multiply that by 4, and when x equals 7, 4 times x minus 4 equals 12. Another example of evaluating expressions when using the order of operations, if I have x squared minus x when x equals 9, I'm going to make sure that I take care of the exponents first. So 9 squared is 9 times 9, which is 81, minus x, which is 9, and so my answer is 72. In this slide, I asked you guys to write to explain how to evaluate this algebraic expression. The expression was 60m, where your variable is m, your constant is 60. Gives the number of seconds in minutes. So how many seconds are there in 7 minutes? Well, you know that the constant is 60. And I'm going to take 60 and multiply it by my variable m. In this case, they gave me m equals 7. And so 60 times 7 equals 420 minutes in 420 seconds in 7 minutes. Let's go over some of the properties that we should know. The commutative property of addition and multiplication says that when adding or multiplying, we can change the order of the numbers and it doesn't change the sum or the product. So order doesn't matter when we're adding or multiplying. The associative property of addition and multiplication is pretty much the same thing, but instead of changing the order, we're talking about changing the grouping of the numbers. It doesn't affect the sum or product. So in this case, for example, if we're multiplying 2 times 4 times 3, I can multiply 2 times 4 first, that group, then multiply it by 3. Or I can multiply 4 times 3, that group first, and then multiply it by 2. But the order doesn't affect the product. Distributive property is extremely important. Multiplying a number by a sum or difference is the same as multiplying by each number. So distributive property says you're going to take that number on the outside of the parentheses and you're going to multiply it by every number on the inside of the parentheses. The identity property of addition is easy. What's the only way that when you add something, a number keeps its identity? Well, it's by adding 0. Adding 0 to a number doesn't change its value. So for example, 9 plus 0 is still 9. The identity property of multiplication is very similar, but in this case, what is it that you multiply a number by that makes it keep its identity? And that would be 1. Multiplying a number by 1 doesn't change its value. So for example, 1 times 7 will have it keep its identity at 7. When I look at a question like this, determine if the expression 3 times x plus 2 is equivalent to 3x plus 6, automatically the property that should pop in my mind is the distributive property. I should be thinking about multiplying that number on the outside by everything on the inside. So 3 times x is 3x plus 3 times 2 is 6. So is this expression equivalent to 3x plus 6? And the answer is yes. So when we're asked to combine these like terms, again, I should be thinking about the distributive property when I see these numbers on the inside of the parentheses and this number on the outside. So I'm going to bring down my 3a plus, I'm going to take this 2 and I'm going to multiply by everything inside the parentheses. 2 times b is 2b plus 2 times 5a is 10a. Now I'm not done because I can combine some like terms here. And what I'm looking for are there terms here that are similar that I can combine together? And I can kind of simplify. So I'm going to look at 3a and 10a, and I can combine those like terms together. 3a plus 10a is 13a. And I cannot combine the b because there are no other b's there. So 13a plus 2b is my final expression. I also asked you guys to write to explain how you know whether 3x plus 12 plus x is equivalent to 4 times 3 plus x. Now the first thing that I want to do is I want to take this 3x plus 12 plus x, and I'm going to put it on this column. And I told you guys that whenever you see a lonely little x like that, make sure that you put a 1 in front of it because a single x just really means 1x. So we can combine like terms here. 3x plus 1x is 4x plus 12. Now I'm going to go ahead and take a look at this next expression, and this one is 4 times 3 plus x. Again, I'm looking at a number outside the parentheses and numbers inside parentheses, so I should be thinking distributive property. Take this number on the outside, multiply it by everything on the inside of the parentheses. 4 times 3 is 12 plus 4 times x is 4x. Is the expression 4x plus 12 the same as 12 plus 4x? Well, the commutative property of addition says that we can change the order and it is still the same. So yes, these two expressions are equivalent. This concludes our review of Module 12. If you have any questions, please feel free to ask.